So here the quarters, actually the first thing I need to remember is that the quarters is actually quite easy to use. So don't worry about how to learn it, or it's not hard actually. So make sure if you everyone can open the canvas, if you open the quarters, you now have that. And so the first thing is we create a new project, and okay, so this is a directory. You can choose a folder, whichever you want. I will just put it on my desktop. The name. So here in this lab 6, I think you are asked to build a half adder, and here I will just show you a very simple demo about just a 2-to-1 N. So let's just call it here. And the project, it can be empty. And we are actually, most of this, you can just leave it there. And for the board, so for the device here, you need to choose the chip. The chip was printed on your board, on your Cyclone 5 chip. And an easier way, actually, you can choose family here. I also got an extension. So you can choose Cyclone 5. And see, the last one will be the D1 SoC board. And this is the device name. You can also search it in the device here. Name filter is this. Or you can just choose the board here, this device. And next, the thing we need to do here and finish. Okay, so next thing is we need to create a file to draw the schematic. Here, this is create a new file, or in the file new, same thing actually. So just remember this Quartus is not hard to learn, so don't worry about this. And design files, there are many kind of design files, and this actually in the EECE 2232, I'm sorry, 2322, you will learn how to use Verilog to write the program, but now we are using the block diagram, or we say the schematic file. So here is a PDF file. This is a block diagram. And so now I will just show you how to find a component here. See, this is a little icon here, the AND gate. This little icon. So first thing you need to know what do we need? Like in the half adder, like you might need the AND gate, OR gate, or even XOR gate. So here for simplicity, we only use an AND gate here. So AND gate, there are many kinds of AND gate. If you just type AND gate in, find any block, is AND gate has many kinds of AND gate. Let's see, we have N2, we have N4, but we don't have N3. This is not in realistics. Not in reality. In reality, we don't have 3 inputs N actually. So I don't recommend you use N3. Like N2 or N4 will be good. I will just use N2 and put it here. Okay. So now we have AND gate. In a half adder, you might need more gates. And we need an input. We need 2 inputs here. Just see there's an input. Okay. Put input here. And further, we need an output. Okay, so actually these steps are all on your tutorial. If you forgot it, you can just check it later in your tutorial. And the next thing is we connect the wires. Right? Just this way. Connect it. And yep, now that'll be now you have finished this AND gate. And for half adder, the circuit will be more complicated, but the same thing actually. Okay. Now, yes. Save. You already finished the schematic, and you save the PDF file in the file. And I'm gonna change another project because this project was got some issues. So same thing. This one is what I did last time. So actually, this that was due and get it. So this is what I did last time. And gate. So here, after we finish this, next thing we need to do is compile. We can just directly click the compile design. But for now, if we only need to check the simulation result. For now, we don't want to upload this file to the board. So actually, we only need to analyze and synthesis, the first one. And you can double click this or click this. And even you can just compile all the design. Both will be fine. Actually. This one is just to check if the schematic has some errors or like the connection errors or maybe a pin or a wire is hanging. So something like this, and it will take some time, like several seconds, I think. But my laptop is kind of old, so it will take longer. Yes, once it finishes. Okay, so once finished, the next thing is we do the simulation. To check, before we upload it to the board, we check it on our own computer, do the simulation, see if the functionality is correct or not. And actually, there are many ways to do this. The one way in the tutorial is to use BWF. So if you want to do the simulation, you have to make sure that you install the model set. I will just show you what if we don't have the model set. See if you didn't install the model set. This one will be blank. I will just show you what will happen if it's blank. So here, BMF. It should be this university program BMF. Okay. And Windows here. So now we have this is like oscillator. So another thing is we want to put this schematic in this oscillator. Just here in this window, right click, insert node or bus, and node finder. This will help us to find all the nodes, and just click the list, see the input and output. They're all there, and we just put them in this oscillator and okay. See the input, this is output. So the input was, by default, it was set to 0. And we can change it. The way to change it is here. There's many buttons here. So this means we don't care, or we don't care the values. Or we change it to 0, or change it to 1. This C is the high impedance. This is something like we make the wire hanging. And this is, I would just like to change this count value is like a period waveform. And first thing we need, we better to define end time. I mean, so how long we need to do the simulation. Now this is 1 microsecond. We can like just do it for 20 nanoseconds. So 20 nanosecond, and for this input, I will just like count every 10 nanoseconds. That means in my question. So that means we create a waveform. This period is 20 nanoseconds, or we say count every 10 nanoseconds. We'll just flip the bit every 10 nanoseconds. It is that. So after this, after you set up all the input waveforms, like now we have 2 inputs. That means we want to check in the truth table, want to check the 0, 0, 0, 1, 1, 0, and 1, 1, right? That will be 4 kind of inputs. And if we have a truth table that has like 3 inputs, then we need actually 8 kind of inputs. So if we have just the 2 to the power of n. Stop there. Wait a minute. And after you set up all these waveforms, so how this waveforms looks like is just totally up to you. And so now I guess I need to restart. So Quartus. Let's go back to the data, and we add all the nodes here. So first, remember we need to set up end time. doesn't allow me to do this. So then I won't change the waveform. Or I will try another input. Let's try this. Let's take it as 15 nanoseconds. And so this period is totally up to you. This okay. It didn't quite. So now we have the two inputs. So even I still didn't run the simulation, so we can just like predict that this part will be 0. This part will still be 0. And let me just set up all the possibilities. So see, this one will be 0, this one be 0, this 0, this should be 1, because 0, 0, only 1, 1 will get 1 for the end. So we can see this one. This button is for run the simulation. If I click this one, I'll save the first one. See a message here. It said model save executable not found. That means when you install the model save, you didn't attach the model save to the Quartus. That because here. So actually, when I first have to run this Quartus, I met this problem, and if you are lucky, you won't have this problem. But I don't know, maybe someone will have that. This model save here, how to find this path or the directory. I will just show you how to do this. Model save. We have the model save here, right? And just make sure you already have the model save. And see, this is model save, the shortcut. And go to the properties. Here it will show you the target, and the first part will be the path. So you can just copy this here. Okay. And now we run it. See, there's no like error message anymore. We can just run it. It will take some time to run test. See, that now the output will be 0001 because only both inputs be 1, the output should be 1. So this is about the simulation. And the next, I think this is all about the simulation. for the part one is about how to upload the top header to the D1 associate board. So this time, if you want to upload upload a file to the board, you have to do all the compile design. It will take some time actually. This time I will type board. So make sure you use the printer cable, not the USB serial cable, to connect the board to your computer. Because now we need the printer cable is also called the J-type cable, and this is what we need. So once you plug in the board, you need to go to the device manager.
Because you got it turns on, right? All right, that's cool. That's cool.
See, because my computer doesn't have the SD1 SoC board driver. If I don't have the driver, then there will be unknown device, and we cannot upload any file to this device. Because it should be a device driver, not it should be a JTAG driver, not an unknown device. We will just solve this issue later. Now, the outline is finished, but another thing is we still need to assign the input and output to the pins on board. In this case, so we need a pin planner. Pin planner is here. See this one? Is click on this pin planner. So you have to make sure that the device is correct. It has to be the E1 SoC board, or say that the certain type, because if it's wrong now, you will see you cannot see the correct. Cannot see the correct pin here. See my device is max 10. It's not the second type. See the pin map here is totally wrong. Actually, it's not the correct one. So we cannot never do this with. We cannot never do a correct design with a wrong device. So how to change this? So anything device. See, we change it to Q. A. Now it's second part. And we need to do all the compile design again. And actually before we do the compile, we can first go to the pin planner And now see this one is second byte. This is correct. So we need to assign the pins. For now, I only have 2 inputs and 1 output. These 2 inputs I want to set it to the switches like switch 0 and switch 1. Switch 0 will be pin AB12. So this is the switch 0 location, should be pin AB12 or just see AB12. And next one will be AC12. And the output, I would like to send the output as the LED one. This is LED 0. So LED 0 will be in B16. So you can just see the whole thing, just type it. So now we already assigned all the pins, and here the IO standard should be 3.3 volts. That one is actually in your tutorial, you'll find LVTTM. Actually, you can run it on the 2.5 volts. That's fine, but it's better you change it to a 3.0 because this is the nominal voltage. So after this, you save it, close, run compile again. It will take like 2 minutes. So will show you what will happen if I don't have, just remember that the board on my computer is an unknown device. What if we don't have that? So when we upload the file, we need to open the program device, this item. And here, see, we cannot select auto detect. That means our computer didn't detect any JTAG here. That means we don't have the JTAG driver. So how to solve this problem? The best way to solve it is just Google it. It's called startup guide. Okay, started. Let's do. Oh, okay, it's called getting started. And we go to the chapter 4. See, the first thing I will just told you that if we find an unknown device, that means we don't have that driver. How to solve this problem? See, we select the unknown device to update the driver software. Update driver, And it should be in the Quartus and see the Quartus drivers. Quartus drivers USB cluster 2. Yeah. So that will just show you how to install driver here. Oops. See. Now the common device was come, and here one more JTAG cables. This is our board, and we already updated the driver here. Now we can use it. And now the compile design was finished, and we open the program device. Okay, so hardware setup. See, if you don't have the driver, this will be blank. But now your computer detect the board, it will just show that the add hardware. Just double click it and close. See, and auto detect. The second one is our chip, whatever. And for this one, please remember to select this one because this is our board. Edit, change file, auto files. I think it should be the last one. And now you can check this and start. See if it's success. This progress will show you that it's 100% successful. And because we cannot access the classroom camera, so I cannot show you. But actually, I can just play the board here, and it just show the correct function of the pancake. So that's actually all about the part pre-lab and the part 1. So for the part 2, you ask to build a full adder. That's will now your job. So this will be all about the demo for the Quartus. Okay, thank you.